Welcome to our week 11 Bellwork for math. Remember that these assignments are given on a Monday or Tuesday of each week and they're due by Friday. Let's go ahead and dig into these review problems. The first problem says, find the first 5 multiples of 7. Well, when I'm thinking of multiples of 7, I recognize that word sounds kind of like multiply. And that's exactly what I want to do. I want to think about my 7s, and I need to think of them as multiplying. So 7 times 1 would get me 7, and 7 times 2 would get you 14, and 7 times 3 would get you 21. And I'll let you continue that idea. If you're not sure about your 7s, another strategy might be to add 10 and take away 3 each time. So 7 plus 10 would be 17. Count backwards 3, 16, 15, 14. 14 plus 10 is 24. Take away 3, 23, 22, 21. And I want to continue that pattern, counting by 7s, whether you call it skip counting or the multiples of 7, either way you'll be able to complete this answer. Let's take a look at the next problem. It says find the difference. If you notice, we're given some whole numbers here. And it would be very difficult, I think, to do our subtraction unless maybe we went to an algorithm and stacked those numbers so that the place values are aligned. So I have 85,730, and I'm going to take away 55,293. If you notice, I usually start with my algorithm in the ones place. And if I have 0 ones, take away 3 ones, I could get a -3. But that might be difficult to see in our algorithm, so what I would encourage you to do is maybe go to the next place value. If we go and we take one of these 10s, we'll leave him with 2. The 10 that we just took, we break into 10 little ones. So we'll have 10 ones, take away 3 ones, gets me, counting backwards from 10, 9, 8, 7, gets me 7 remaining ones. I'm going to try this again, but I move to the 10s place. So I have 2 10s and I want to take away 9 from them. Well, while I could do that and I could use 7 10s, I'd prefer not to because we're working in our algorithm. So let's instead go to the hundreds place. Could we take one of these hundreds and leave him with 6? And now that 100 that I took, I break into 10 10s. So 10 10s plus the 2 10s that are there gets me 12. 12 take away 9. Well, in this case, I might count up from 9. I put 9 in my head and I count up 10, 11, 12. With some tallies, I see that I'll get 3. Let's move to the hundreds place. Here we have 6 hundreds, take away 2 hundreds. Well, I will not get a negative from that result, so I can go ahead and do that subtraction. Maybe I keep the 6 in my head and count backwards 2, 5, 4. I'll get a 4 in the hundreds place. Let's go ahead and move to the thousands place, and I hope you recognize that we have 5 thousands and we're taking all 5 of them away. I'll be left with nothing in the thousands place. And I'll move out here to the 10,000s place, and I have 8 10,000s, using up 5 of those 10,000s. Well, let's try counting on again. So I'll put the 5 in my head and I'll count up to the 8. 5, 6, 7, 8. That took 3 extra groups of 10,000 to get there. If I go ahead and put in my notation, I could read this final answer as 30,437. Let's take a look at the third problem, where it says, in which quadrant would you find the ordered pair -7, -2? And if you look at this coordinate plane, you might say to yourself, I can't even see the numbers. In fact, I cannot either. And I just gave you a small sketch here as kind of a hint that we always want to think about the x-axis before we consider the y-axis. We always go across before we can go up or down in the elevator. Well, if I was given the first number of -7, you would hopefully remember that I'm either going to have to move right or left to get to that number first. First, I move across. Well, starting here at the origin, I would move -7 to the left. Negative numbers are behind the 0 on the x-axis, and positive numbers are in front of it. So I'd be moving here to the left somewhere. The next number says -2, so I hope you remember the second number is telling me whether to go up or down in the elevator. So after I move back 7, I'd move down 2, because my negative numbers are towards the bottom while my positive numbers are towards the top. So again, first number negative, move across to the left. Next number negative, go down in the elevator. you'd land somewhere down here. And this is just a sketch just to kind of get me thinking about quadrants. Now I'd really encourage you to open up your planner. I believe you'd want to be on page R9, and I think you would find not just your multiplication chart there, but also a little chart that shows the coordinate plane and its quadrants. Well, looking at our quadrants, I hope you remember that the first quadrant always starts in the upper right. The second quadrant is to the upper left. The third quadrant is below the second quadrant, and the fourth quadrant, even though it's written with Roman numerals, oops, I just made that 6 by accident. It should be IV. Even though it's written with Roman numerals IV, it stands for the fourth quadrant, is in the lower right. So which quadrant did we land in? You might recognize that we landed in this quadrant with 3 I's. That's also the same as quadrant 3. And I'll use a Roman numeral to answer that. That's usually how we indicate our coordinates, or our quadrants in the coordinate plane. Moving right along, we'll take a look at our fourth problem here, which involves order of operations. It's so important if you go in for an operation, you come out having the right thing done. So same idea with this math problem. When we talk about order of operations, we want to follow a routine set of rules. So I look over here and I gave you a hint of PEMDAS. The first P tells me to look for any parentheses or grouping symbols. So parentheses are kind of those rounded bars, while brackets might look more like this. Do we have any in this problem? In fact, we do. We have 2 sets. So I notice that there's a set of parentheses sitting here, but outside of those is a set of brackets. So in order to end up with a successful answer, we want to make sure that we always handle the innermost grouping symbols first, the innermost, the ones that are on the inside. So take a look, which parentheses or brackets are on the inside. You might notice that I have this 2 times 5 on the very inside of another set of brackets or braces. So what is 2 times 5? Hopefully you'd know. We'd count by 5s, 5, 10, I'll get 10. And I need to remember to bring down everything I have not used and maybe cross off the parts that I have. So I took care of those parentheses inside, but I sure haven't used the subtraction in front of it or the 37 I was given. I also have not used these brackets that are around the 37 minus 10 now, or the 3 right in front of that bracket, or the addition in front of the 3, or the 4 to the second power in front of that. I'm really ready to look for the next step. So we took care of parentheses, but if you notice, I can't move on until I've taken care of all sets of parentheses or grouping symbols. So I have another set sitting right here. They look more like braces or brackets. So we're going to make sure we do that next. 37 take away 10. Well, I can kind of picture that in my head. The 3's in the 10's place along with the 1. 3 10s take away 1 10. Gets me 2 10s. And the 7 never changed. I didn't take anything from it. I should get 27 there. Now I'm thinking about taking off these brackets, but if I do, you have to notice that there's a 3 sitting right in front, and that could cause us some trouble. So for that reason, even though there's not much to combine with that 27 any longer, even though I took care of what was going on inside with the subtraction, I need to make sure I keep those brackets on there. I'm going to bring down anything I have not used. The 3 sitting right in front, the addition right in front of that, and the 4 to the second power in front of that. Are there any parentheses or brackets to deal with? You might say yes, because I see that 27. But can we do anything with the 27 on the inside? The answer is no. So we're going to be done with our parentheses step. Do we have any exponents? Those little tiny floating numbers? Oh, we absolutely do. We have an exponent of 2 and a base of 4. So off to the side here, I gave us a hint. We want to figure out 4 to the second power. Well, if you remember, it's all about the base. We want to take that base, that large number, and we want to write it however many times we're told to with the exponent. So in this case, we write it 2 times. We want to say to ourselves, well, what's 4 times 4? And hopefully you can think 4, 8, 12, 16. 4 times 4 is 16. Most popular wrong answer from 6th graders, they love to tell me that that's 8, but it's not. It really means 4 times 4, which gets me 16. I used up that exponent, so I'll cross this part off. I'll bring down anything I have not used yet. All right, are there any other exponents, you might ask yourself before we move on? And in fact, there are not, so I'll cross the step off. Next, I'm looking for any multiplication or division. That M for multiplication or D for division is a good reminder. And if I look here, I actually do have something like that happening. But do you see it? Sometimes this takes a very sophisticated math eye. If you take a look, the 3 is sitting right next to this parenthesis or this grouping symbol. So when that happens, there's secretly multiplication happening in there. We're going to have to multiply as the next step. Well, what is 3 times 27? Hopefully you'd say, well, I know 3 times 20, that's 60. And 3 times 7, that's 21 more. Well, 60 plus 21 should get me 81. And I'll bring down everything I have not used and cross off the parts that we have taken care of. That doesn't really look much like an addition sign, so I'm going to try to fix that for you. We took care of the multiplication. It was kind of hiding. It was right next to a bracket, wasn't it? But we were able to spot it with our math eye. So the next thing we look for is addition or subtraction, and we do have that left. So your last step is 16 plus 81. If I were you, I'd probably take that and rewrite it off to the side and see if you can come up with a final answer. If we've done a good job of organizing this, when you're finished, you've just made me some pizza. No, you don't actually have to draw the slice. But do you see how we're going to get a final answer? And with order of operations, we continue to get smaller and smaller and smaller until we get down to one answer or one solution. Let's go ahead and see if we can find the quotient with 2 fractions in a division problem. So, next problem says find the quotient. Well, that really just implies we need to find the answer to a division. That's what it's showing us here. And here's my hint for you. We could keep, change, flip, or KCF, sometimes we say. Now, it will never say that on a test for you, most likely. It's going to say something like multiply by the reciprocal. Well, that's something we could do. Could we go ahead and keep the 4/8 the way it was given to us? Absolutely. What would we change our division to? Hopefully you'd think of its opposite. The opposite of dividing is multiplying. And last it says flip. Well, that means we're going to have to turn our second fraction into its reciprocal. Those numbers are going to look like they flip positions. So the 6 that was on the bottom moves to the top, and the 4 that was in the numerator moves to the denominator. I'm really ready to multiply, but I'd say hold up. Do you notice that we have some cross-simplifying that's possible? These numbers that are across from each other could be simplified a little bit to make our numbers smaller to work with along the way. So let's ask ourselves, what goes into both 4s nicely? Well, 1 divides into all numbers, but that won't really change their values. So what about 2? Yep, they're both even. But is there anything bigger? Oh, doesn't 4 also divide by itself? By 4? Let's go ahead and divide by the greatest common factor of 4. How many times does 4 go into itself? Well, anytime a number is divided by itself, we'll get 1. And notice I write that 1 on the outside. Same idea on this bottom right corner. I have 4 divided by 4, and I will get a result of 1. Now, what about the other numbers that are written diagonally? Could they cross-simplify? Do they share any common factors? Well, hopefully you see 8 and 6 are both even, so that probably means I could divide them both by 2. But is there anything bigger? If I was looking at my multiplication chart, I'd look right across and see if I can find 6 and 8 in the same row. Well, I do see them in the 2s and in the 1s, but not anything larger. So we're going to divide them both by 2. 2 goes into 6. Let's count. 2, 4, 6. That was 3 times. And 2 goes into 8. Let me count by my 2's again. 2, 4, 6, 8. 4 times. I'm really ready for a rewrite step, and I have to warn you that this gets a little bit messy if we have so many cross-simplifying ideas going on. So I'm going to make sure I take my new numerator over my new improved denominator, and my new numerator of the second fraction over my new improved denominator. And this again is multiplication. We have changed to a reciprocal approach. Well, no other cross-simplifying that I see, so in this case I'm going to multiply straight across, and I know 1 times 3 is 3, and straight across to my denominator, 1 times 4 is 4. Oops, I do think I said that right. 1 times 4 is 4. Yeah, there we go. 3/4 is the final answer. That's what they're looking for. I do wonder if we could do this with a model real quickly, and I will try that just in case you're curious because you're working on that this week in class. So taking that first fraction and trying to break it into 4/8. Well, here I have halves. Now I have fourths. Split those again down the middle, and I have eighths. But I have 4 of them. 1, 2, 3, 4/8. And I want to split them into sixths. So underneath, I'm going to try to split these into 6 equal parts. First I could start with thirds. Split those again, and I would get 2, 4, 6 parts. And I'm trying to make a group of 4, 6. These don't line up very nicely, do they? So I might say to myself, what is a number that works for both 6 and 8 nicely? And maybe you think to yourself, let's see, count by eighths, 8, 16. 16 doesn't work for 6. 24. Oh, 24 works for both of them. If I did that, I would really have to split all of these into 24ths equally, and that could be pretty challenging in my opinion. Here I go from eighths to 24ths. Each of these get chopped into little tinier pieces so that I get 3 smaller parts out of each chunk. So 3, 6, 9, 12, 18, 21. Did I do it wrong? Let me think about this. 3, 6, 9, 12, 18, 21, 24. I'm getting 27ths. I did something wrong. 3, 6, 9, 12. Helps if you can count by threes. 15, 18, 21, 24. There we go. We've got 24 little tiny pieces. I did split it correctly. I just couldn't seem to count. Next I have 4 sixths, and we said that they both share a common multiple of 24. So I'm thinking about turning them into 24ths. Well, to go from 6 pieces to 24 pieces, I have to multiply by 4. I need to split these into 4 smaller parts. So 3 lines in between each of them. And I'm thinking this is not the right strategy for me to be trying with these numbers the way they're written, because it's getting pretty complex and pretty hard to look at. But if you notice, I'm trying to make groups of 4 sixths, or that's equivalent to starting here and ending there. That's the same as 4, 8, 12, 16, 24ths. So I'm trying to put 16 in a group. Well, if I count up here, I have 3, let's hope I can count it again, 6, 9, 12. I only have 12 of the 16 I need. So 12 of the 16 I need. If I divide the top and the bottom by a common factor of 4, you will find that I end up with the same result of 3/4. It does check out with the model. That model wasn't great for me because I ended up with very small pieces and my counting skills weren't so hot on a Sunday evening. All right. Moving to the next side of week 11's Bellwork. We get to review some statistical terms. It says find the range and the mean of the following data set. Well, first of all, it says range. And if you take a look, over here I gave you a hint, the range. They're taking not only the 9 and the 3 from this, I want you to recognize that the 3 is the minimum and the 9 is the maximum. And they did a subtraction. Let's try the same idea. Can you find for me the largest number here? Is 43 the biggest? No, 47 is bigger. Anything bigger than 47? Oh, right there. 52 is the maximum. Well, next I need the minimum, the tiniest number. 18 looks pretty small to me. Is there anything smaller than 18? No, that's the minimum. I'm ready. I'm going to take the 52, the maximum, and I'm going to subtract the minimum, and there is a bit of a regroup here, but when you are done, you are going to find the range. So just getting you started on setting that up at this point. The next thing it says I need to do is find the mean. It says, hint, add all the numbers, count how many, add all the numbers, count how many, then divide the total by how many numbers there are. So this is talking about finding the sum. And when I'm done finding the sum, I need to divide by the number of numbers I was given to find the average. So off to the side, perhaps, I'll move this again. We're going to take everything we were given, the 43 and the 47 and the 32 and the 18 and the 52 and the 32, and I'm stacking them up and adding them up. You could really add down in the ones place and do a regroup here into the tens. You could try some number bonds, like here I see 40 and 40 gets me 80, 7 and 3 gets me 10 more. I'll get 90 from those two numbers. Here 30 and 10 gets me 40, and 8 and 10 gets me 10 more. I'd get 50 from those two numbers. I'll try a number bond with these also. Well, 50 and 30 gets me 80, and 2 and 2 gets me 4 more, 84. I could really go and add 90, 50, and 84 to get my final result. That would be the sum. And when I'm done, I'm going to put that sum inside my long division symbol. What will you have to divide by? The number that you're going to get is going to be pretty enormous. In fact, I think looking at it, I'm going to get 224. Well, we're going to have to make sure we have a number that's an average. It lands somewhere between the minimum and the maximum. So I'm going to have to divide next, it says. Divide by the number of numbers you were given. So here I have 1, 2, 3, 4, 5, 6 numbers. I'm going to end up dividing that 200, I think I forgot what I said here, 140 plus that, or 224 by 6. And I actually think it may go in there nicely, which would be really nice. If it does, we'll get a whole number answer, a whole number average. If it does not, we can always write it as a mixed number, and that sometimes happens when you're working with numbers that are quite large. All right, let's go ahead and maybe pause your video, take a minute, see if you can come up with a solution on that. I hope you're back from trying that problem. I actually worked on it just a moment ago, and I want to make sure that we take a look at it because I think we do end up getting a mixed number. So I have 0 plus 4 gets me 4 in the ones place. Next I have 9 plus 5 gets me 14 plus 8 more. Well, I could use my dots here, 14, 16, 17, 18, 19, 20, 21, 22. That's where I thought we'd get that 224 from. Well, when you go and divide, that 6 doesn't go nicely into 2, but it will go nicely into 22. It goes in there 3 times because 6 times 3 is actually 18. When you're done, we could count up from 18, 19, 20, 21, 22. That takes 4 more. There will be 4 left here, won't there? And I can bring down the next place value and treat 44 like a number divided by 6. Excuse me. 6 goes into 44 7 times if you look at your chart, because 7 times 6 is actually 42. And when you subtract, you're left with 2. This did not work out quite as nicely as I was hoping, but it still gets me an exact and final answer. This really is the same as 37 and 2/6. But before you frame it, before you say, ta-da, that's my mean or my average, I would say, be careful. Do you see that we could do something with the 2 and the 6? And in fact, we can. When you can simplify, do simplify. Both of those are even numbers. So we're going to end up rewriting this a little bit. We'll still have 37 whole groups, but our fraction's going to get a little bit smaller looking in number value, and it will still be our mean. Again, remember you're looking for 2 different answers on this part of your warm-up or your bell work, the range and the mean. Let me go ahead and clear what I've done here. If you have to go back and fix something, now would be a great time to do so. And here we are looking at the next problem. Place the following integers in order from greatest to least. This is unusual. I have to point out for you, oftentimes they say from least to greatest. Today they turn it around, the greatest to the least. Well, out of these numbers, if I think about money, which one would you rather have? Would you rather owe someone $23 or have 19? I hope you'd say 19 must be the greatest. Are there any other positive numbers that wouldn't be too bad to have? Oh, I wouldn't mind having $1. How about you? But now if you look, I'm left with just negatives. And I really don't want to owe anyone money, but if I had to owe someone something, would it be better to owe them $23, $33, or $3? I hope you'd say -3. So I'm really working my way backwards on the number line. I need you to give me the 2 remaining integers in order, but remember, we're trying to end up with the smallest, the least, the one that is farthest away from 0 in the negatives when I'm done. Some of you might be a little bit upset this week. You might say, hey, Mrs. Schumann, you used to give me all the answers, and this week you're making me do a little more on my own. There is a reason for that. I do get concerned that sometimes students aren't doing their own thinking and working. So today, pushing you a little bit more than maybe you're comfortable with, but that's a good problem, I think. The last problem says plot the fractions on a number line. Hint, you may start with bar models if it helps you. They give me 1/2 and 3/4. We'll take a look at that 1/2. We've been talking about fraction strips this week a little bit. And if I wanted to show you 1/2, I could draw one whole bar like I did here for you. The whole bar is drawn, and I split it down the middle so that I have 2 parts. And I only have one of those remaining. That represents the 1/2. If I think about that on my number line, that really means that the 1/2 is going to be halfway between the beginning and the end of those whole numbers. What if I did the same thing with 3/4? If you notice, I gave you a whole bar, and I made it the same length intentionally so. It's the same length as my number line, really, from here to here is what I was going for. And I split it into 1, 2, 3, 4 equal parts. But according to the problem, I only have 1, 2, 3 of those 4s. So I'm going to shade in 3 of them for you right now. That means that this would start at 0, and then I would start hopping until I got over here at 3/4. So I'm really ready to put these on my number line, and when you're in this situation, you can really bring down the different intervals that we made, the different sections that we made. So the first section I see here comes from this 3/4 bar. The next section I see aligns for both of them comes from the middle, and then the next section I see that we made came from the 3/4. Well, I know the 1/2 has to be here in the middle because if I look up, that's where it was located. It's in the middle. And if we think about that, 1/2 is in the middle of which 2 whole numbers? If I have half a cookie, isn't that more than having 0 cookies? But it's a little bit less than having 1 whole cookie. So I really want to show you 0 and 1 on my number line as well. The next thing I want to show you is the second bar model, which gave me the 3/4. I can bring that 3/4 straight down into my number line. And my question for you is sitting right here. How would I number or label this? Well, let's count our intervals. How many parts did we split our number line into? It's split into 1, 2, 3, 4 equal parts. So I'm really counting by fourths. On our early unit, it said use an interval of 1/4 for numbers between 0 and 7 or something along that line. So I'm using intervals of 1/4. It really is telling you count by 1/4. So here I have 0/4. Next I have 1/4. And then 2/4 would be another name for this next stop along the way. Then 3/4. And I could say 1 is the same as 4/4 if I wanted to. I could rename it. The only thing I would caution you about is all good number lines should have points. So I want to make sure that you're giving me a point located at both of these locations. A point should be located at 1/2 and another point at 3/4. And notice I have more information on my number line, which is fine as long as they don't have points. They just help me to locate and be accurate on my number line with my intervals. I hope you find this a good review for the week. I hope you find it a little bit challenging because there are some bits and pieces that I need you to finish on your own. And I thank you for watching my YouTube channel. I hope it's giving you a few pointers along the way.